Okay, this is the bonus lesson on scientific notations and unit conversions. We will be going over this in class. I actually haven't got time to mark the your exit cards that you handed in yet, but we'll do this here anyway, and then I'll see how much time we have to spend during class to go over some of these things. First, we're going to talk about scientific notation because this is something you should have learned before. What scientific notation is writing very annoying numbers like this, and the one that we've been writing often is 300 million, right? So writing numbers like that gets tedious, tiring, and it's not very good to punch all those zeros in your calculator, and then you have to keep counting like how many zeros you put in if you like mess up the count, etc., etc. There's like a lot of problems writing all these zeros, especially grade 11 and 12. If you continue doing chemistry or physics, you'll be doing a lot of small numbers and big numbers, and so we can't be putting all those zeros into our calculator each time. So what scientific notation is a shorthand way to write that using the symbol times 10 to the power of. So that is right there is what scientific notation is all about. So we know that 10 to the power of 1 is 10, 10 to the power of 2 is 2 zeros, 10 to the power of 5 is 5 zeros. We also know that 10 to the power of negative 1 is 0.1. 10 to the power of negative 3, 0.001, because 1, 1, 2, 3 decimal places. We've moved backwards. Should draw it the other way. 1, 2, 3. That's 10 to the power of negative 3, so on and so forth. Basically, what we're doing here is you can see the answer. We're multiplying 5.6 by 10 to the power of 5, which is actually 100,000, right? And we get 560,000. Okay, practically how this works, so that's the meaning of how we write scientific notation. We're just writing, we put the decimal point. So right now, if I just write 5, 6, and 4 zeros, the decimal point comes after the 4 zeros. That's the end of the number. This is the ones place right here, so the decimal point comes after that. Scientific notation means that the decimal point has to be after the first digit. So we want the decimal point over here. Correct? So we figured out how many places we've moved it. 1, 2, 3, 4, 5. We moved it 5 places. And because this number is greater, the magnitude of this number is greater than 1, we use the positive power, right? 5.6 times 10 to the power of positive 5. We can't write negative 5 here because that would make it a very small number. Does that, hopefully that makes sense. For example, of a small number, we come here, 0.0000000013, whatever. Again, we put the decimal point is right here for the time being, so I'll write it out again just so that we have 4 more. 1, 2, 3, 4. Okay, I think that's it. Decimal points over. We want the decimal point right up here after the first non-zero number. So after the first number that is not zero, basically. We figured out how many places we moved it. 1, 2, 3, 4, 5, 6, 7. We moved it 7 places, and this is a very, very small number, so we're going to write negative 7. So, because technically this is the decimal point is if it was 1.3, we have to move it 7 places to the left to get this number. So we add negative 7. If the decimal was after the 5, we have to move it 5 places to the right. So it's a positive exponent, positive 5. All right? The negative and positive really I hope you don't get too confused over them because they really correspond to whether the number is a big number or whether the number you're expressing is a small number. Now, expanded form is the same thing, 6.7, and we're basically going to multiply it by 10 to the power of 6. So we're multiplying it by 1,000,000. So we're just going to move the decimal place 6 places to the right because it's a positive power. We're going to get a big number. So just for the sake of it, we're going to add a bunch of zeros so that we can see where we're moving. 1, 2, 3, 4, 5, 6. So that's 6, 7 followed by 1, 2, 3, 4, 5 zeros. And that's the answer right there. 9.4 times 10 to the power of negative 3. So we're going to add a bunch of zeros before because we're going to make this a small number because the exponent of the 10 is negative. So we're going to move this decimal place 1, 2, 3 back, and that's 0.0094. So that's the answer shown there. Okay, hopefully I can erase all this. What did I do? Okay. Edit, erase. It's not erasing. Oh, I did erase. Okay, we're back in business. Megahertz to hertz and nanometers to meters. Now, these ones are a bit more difficult. They might be difficult if you don't or aren't familiar with the 3 rule of the unit conversion. So let's use meters as an example, right? So 1 meter. Do we want to do it with 1 meter? Sure, let's do it with 1 meter. There are units that are smaller than a meter because a meter is sometimes too big to represent things like the wavelength of visible light. Wavelength of visible light, if you'll remember, is around 400 to 700 nanometers. So nanometers is 1 billionth of a meter, right? So a meter, we can't really say 0.000000004 meters. Instead, we use nanometers because that's a much easier way to say. It's much easier to say 400 nanometers. So this here is millimeters, and then we go down to micrometers, then we go down to nanometers, and each jump is a power of 1,000. So 1,000 millimeters is 1 meter. 1,000,000 micrometers is 1 meter. 1 billion nanometers is 1 meter. So whenever you see a number like 400, or let's do another one. Let's just do 4 times 10 to the power of negative 9 meters. Right? What we can do is basically change this 10 to the power of negative 9. 10 to the power of negative 9 meters we know is 1 nanometer. Right? Hopefully you're not confused by just because this negative is here. 1 meter is 10 to the power of 9 nanometers. So 10 to the power of negative 9 meters would be 1 nanometer. Hopefully this thing is clear. It's often kind of confusing when you start using it, but hopefully we'll get used to it as we do more. We'll definitely do more practice of this, but hopefully you guys are good with the scientific notation and expanding that stuff that we just talked about before. The same way, if we were to go this way, you have kilometers, megameters, gigameters. So those are your prefixes that also go in powers of 3. So 10 to the power of negative 3, 10 to the power of negative 6, that's 10 to the power of negative 9. So 1 meter is 1,000th of a kilometer, 1 millionth of a megameter, and 1 billionth of a gigameter. Right? So that was that. We'll talk about this more in class, and I'm going to say my time limit for videos now is going to be 10 minutes. Hopefully that's not too long. We'll see how it goes. But I will sign off, and then we will continue our discussion on these prefix SI unit systems in class. All right, see you guys later.